Alright guys, welcome back. We're going to be solving another question from the third chapter of Meriam textbook, and in this one we have this group B of the wood clamp that is tightened so that the two blocks are under compression of 500 Newton, and we need to determine the force in a screw A. And we have a note that the force supported by each screw may be taken in the direction of the screw. So probably the biggest takeaway from this message is about the direction of the forces that we have in here, and that's why we have the note at the end of the question. And so basically what's going to happen in these two wood blocks is that we will have these two forces from the clamp to the woods, and if we want to draw the free body diagram for the upper side of the clamp, so this will be the upper side. So obviously the woods are in compression, meaning we have a force in the opposite direction from the wood to the clamp, and from the question we know that force is 500 Newton, and we have two screws that from the question, so the A is going to tighten the two parts together, so the force that is applying from the A is downward, let's call it A, and the force from the B part, so the screw is gonna get tightened, meaning putting pressure on the upper side of the clamp. Let's call this one B, and everything, we have all the distances in here. We can go with the bottom one too. We will have the same story. So what we are interested is in the force in the screw A, so if we just do the moment about point B, calling counterclockwise positive, we can cancel out the moment of point B, and the only unknown that will end up at is the force in the screw A. So let's figure out the moment here. So we have the moment of 500 Newton, which is clockwise, so we have a negative moment 500 times the distance, basically the distance from B to A, which is 100 millimeter plus 150 millimeter, which is 250 millimeter, and in order to get it in meter, we're going to divide it by 1,000, so that would be meter. And we have the moment of the A, which is, we can see, is counterclockwise, so we have positive A, and the distance would be from A to B, which we know is 100 millimeter, again divided by 1,000 to get it in meter is equal to 0. One unknown in here, which is A, and if we calculate this, we'll get 1250 Newton for A, which will be the final answer for this question. So all of the equations that we are using in here is based on the equilibrium equation. So we have the sum of all forces and sum of all moment equals 0, and we only use the moment equation about point B in order to find the unknown that we were looking for. So yeah, that's about it for this one. Please let me know if you have any questions regarding this one or the three textbooks that we're covering in this channel. Feel free to drop your questions in the comment section. I'd be happy to answer those. Don't forget to subscribe to the channel, like and comment, and I'll see you guys in the next video. Have a good one.